The first part of the Chapter 2 practice test covers sections 2.1 through 2.4. There were a bunch of formulas in those sections, and you don't have to memorize, I don't think, any of them other than maybe the Pythagorean Theorem. This sheet that's up on the screen right now, you're going to be given on the test. It'll probably be the front page of the test. I'll just say tear this off and use it. So you don't have to have any of these formulas memorized. The stuff at the bottom of this sheet, the Roman number stuff, that's from section 2.5, and you might have not seen it yet. You don't need to worry about it, but it's going to be given to you on the test. So I'm going to jump into the problems and check my answers off screen. I'm not going to show the answers every time. I'm just going to make sure my answers are correct. The best thing you could do right now is actually do the whole practice test part 1 before watching the video, and then any problems that you got the wrong answer because you checked your answers, you should just fast forward to that part of the video, watch how I got the answer, and not worry so much about watching me do every single problem that you already know how to do if you already know how to do them. Alright, so problem 1 has a bunch of parts. The first part is to find the missing length using the Pythagorean Theorem. And then the second part is then find the area and the perimeter of each of these triangles. And for whatever reason, I didn't find triangles that had units marked. So I'm going to assume that all the lengths are in centimeters. So when I go to do problem 1a, I'm going to assume that the given lengths are in centimeters. Similarly for 1b, 1c, and 1d. When I do 1a, I guess I deleted 1c and 1d. So when I do 1a and 1b, I'm going to start off using the Pythagorean Theorem to find the length of the missing side. So I'm going to use the formula a squared plus b squared equals c squared. And I know that the c has to be the side that's opposite the right angle. If this side was marked as A, this means this 9 must be B. So into the Pythagorean Theorem, I'm going to leave A as an A, and I'm going to plug in 9 for B, and I'm going to plug in 12 for C, and I'm going to do some exponent work in my head because I know that 9 squared is 81, and 12 squared is 144. I need to solve for a, so I'm going to need to get the a squared isolated, and then I'm going to square root in a second. When I do this and do 144 minus 81, I get 63. So I get a squared equals to 63. And then I'm going to square root and round to 2 decimals. If you instinctively wrote your answer to this problem as a reduced square root, I can be very happy with that. But for me, I'm going to say my side, the missing side, was labeled A. I'm either going to leave it at 7.93 or I'm going to round to 7.94. The number in the third decimal place rounds that 3 up to a 4. But if you wanted to, if you said 3 square root of 7 is what side A is, I can completely live with that. The thing is, if you do the radical answer, it's going to make it hard to do to the perimeter, and it's going to be hard to do the area. And better yet, when I go to write my answer, I should probably put units down. So part of my answer, I need to find the length of the missing side. The missing side on this triangle was labeled A, and I said that the lengths are in centimeters, and that's the length of a side, so I'm just going to put centimeters down. The next thing I'm going to do is find the perimeter. And to find the perimeter of any triangle, you just add up the length of the 3 sides of that triangle, and I'm just going to add up the 7.94, the 9, and the 12. I think I get 28.94, but my calculator will make it so I don't make a mistake. And so I get perimeter. And again, perimeter, the units don't have squares in it, so second part of my answer is going to be P for perimeter. The number is 28.94, and my units are centimeters. And then I need a formula for the area of a triangle. The area of a triangle is base times height over 2. And in a Pythagorean Theorem type triangle, the base and the height are going to be the sides that make the right angle. I'm going to call this side the B, or the base, and this side with the A, the height. But as long as I didn't use the C in my computation to find the area for problem 1A, I'll be fine. So So last computation, area equals base times the height over 2 is the formula. And base is 9 centimeters. Height is 7.94 centimeters. And then over 2. I'm going to round to 2 decimals again because that's what the instructions tell me to do. So just simply 9 times 7.94 divided by 2. I get 35.73, and that's going to be the end of my answer once I get the right units attached to it. And the units I'm going to attach to it need to be square because it's area, and I'm going to write centimeters squared. So my answer to problem 1A are those 3 individual amounts. Side A is 7.94, perimeter is 28.94 centimeters, the area is 35.73 centimeters. For part B, the side that's missing doesn't have a label, but it's across from the right angle, so it must be the C. These other 2 sides, it doesn't matter which I call A and which I call B. Those are interchangeable. I'm feeling motivated to call A the 8 centimeters and the B the 18 centimeters. And now I'm going to use the Pythagorean Theorem to find the missing side C. So I'm going to say 8 squared, which is my A squared, plus B squared, which is my 15 squared, equals to C squared. This is going to be 64 plus 225 equals to C squared. This gives me 289 equals to C squared without using my calculator, just because I could do that in my head. And then I can square root both sides. On the right hand side, when I square root C squared, I get C. On the left hand side, the square root of 289 is 17. So part of my answer to 1B is the missing side, and I'm going to call it C because that's a really appropriate name for that side. I'm going to say C is 17 centimeters. The next thing I'm going to find is the perimeter, and to find the perimeter, I'm just going to add the 3 lengths, 8, 15, and 17. And that's 23, 33, 40, as near as I can tell. And I'm going to attach units when I go to write my answers. I'm going to write P for perimeter, and then centimeters for the units. The last thing I need is to do the area using the base times the height over 2 formula. And again, in any Pythagorean theorem right triangle, the base and the height are the non-C parts. And it kind of doesn't matter which of the 2 sides you call the base and which you call the height, because you'll get the same answer regardless of which side of the 2 legs that aren't the hypotenuse you call base and height. I'm going to call the base 8 and the height 15. If you called them reversed, your numerator, when you do the fraction, is going to be reversed, but it's going to come out to the same number. You're either going to have 15 times 8 over 2 or 8 times 15 over 2 when you do the Pythagorean theorem for the area, and it's going to be the same number. For me, the number I came out with when I went to do my area is 60. In my answer, I need units, and because it's area, I need square units. And because the lengths are supposed to be in centimeters, it's going to be in square centimeters. So I've checked all these answers off screen to know that I haven't made a mistake. Problem 2 gives me a couple of parallelograms, and it wants me to find both the perimeter and the area. I'll do the area first, and I'm going to get the area formula from my sheet. So this is a parallelogram. The area is base times the height. So to find the area for number 2, I need the area formula, and the height is always the internal line that doesn't get used in the perimeter computation. So the height, or the h, is going to be 5 centimeters, and the base is the length of the side that the height connects, and so this 15 is going to be the base. So the area for this I'm going to get by taking 5 times 15. As a number, that's going to be 75. I need units, and for area I need square units. And I'm going to put 75 square centimeters. When I go to do the perimeter, I need to add up the length of all 4 sides. I'm not going to choose the height. That's not part of the perimeter. It's internal and not along the edge. And I'm assuming that opposite sides in a parallelogram have the same lengths. So this top side that wasn't measured indicated has a 15 centimeter length, and this side off to the right has a 2 centimeter length. Lots of ways to get the perimeter. You just have to add up all four sides. So I have two 15s and two 7s. I could just say it's 7 plus 15 plus 7 plus 15, or I could say it's 2 times 15 plus 2 times 7. There's a bunch of ways to do this. When you add these up, you get 44. And in my answer, the number that needs to go for the perimeter is 44. The units are just centimeters. You don't get square units when you do perimeter. For problem 2b, the lengths don't have units on them. It says to assume they're centimeters, so I'm going to write those in so I don't forget. First thing I'm going to do is the area. The 12, which is inside, not part of the perimeter, is the height. The 20 is the side that the 12 connects to. That's the base. For the area, it's going to be 20 times 12, and 20 times 12, I believe, is 240. So part of my answer to 2b, the numerical part is 240. The units part has to be centimeters squared. And when I do the perimeter, I'm going to add up all four sides. And the unmarked sides, I know that they're equal to the opposite sides. If I want to be slick to do this, I can say there's two sides that are 13 and add that to the two sides that are 20. So this is an alternate way. I could have just did 13 plus 20 plus 13 plus 20. This is an alternate way, a slicker way to add up the four lengths, because there's two 13s and there's two 20s. Regardless of how you add them up, the perimeter for this parallelogram is 66. I need to put the units in, and for perimeter you don't get square units. 3 gives me trapezoids. I'm going to do both the area and the perimeter again, and for me the area is harder. The area formula is given for trapezoids. It's little b plus big B times h over 2. So the formula that I need to do the area part of this is little b plus big B times h over 2. The h is the internal part that doesn't get included in the perimeter. That's the 3.2 feet in this problem. And the little b and the big B are the lengths of the sides that the height connects. I'm going to make the shorter of those two sides little b, and the longer of those two sides big B. So when I go to find the area for this, I'm going to do little b, which is 3.4, plus big B, which is 5.3, times the height, which is 3.2, over 2. And when I go to write my answer, I'm going to write A for area. The units are going to be feet squared, or square feet. And then I'll just do the rest on my calculator, and I'll round to 2 decimals if I get more than 2 decimals. I'm going to go 3.4 plus 5.3 times 3.2 divided by 2. And my calculator gives me a lovely 2 decimal answer, so I'm going to leave that. And in my answer, the numerical part for the area is going to be 13.92, and the units are square feet. And then I'm going to do the perimeter. To do the perimeter, I add up all the external sides and not the height. So to do the perimeter here, I'm going to go 3.4 plus 3.7 plus 3.2 plus 5.3. I have no desire to do that by hand. And I get 15.6 for the perimeter. Have to have units, even though I'm not including units in my work because they're just kind of cumbersome to do. Perimeter always has linear units, so in this case it's just going to be feet. Problem B has the same formula. I actually had the area formula here. I'm going to call the height the 2.7, the little b the 2.1, the big B the 4.5. You can interchange the little and the big B. Usually I make little b the shorter of the sides that the height connects and the big B the longer, but it doesn't really matter. So area equals little b 2.1 plus big B 4.5 times the height 2.7 over 2. All calculator. I wouldn't expect anybody to do this by hand unless you just liked doing stuff by hand. And I get 9.4 8.91. So part of my answer to 3b is the area, and I need to have units. The numerical part is 8.91. My units are going to be meters squared. For the perimeter, I just add up the sides 4.5, 3.0, 2.1, and 3.0. Probably could do that without my calculator, but it's silly to do it without my calculator because I'm just going to make a mistake that I don't need to make. I get 12.6 for the perimeter. In my answer, I'm going to say the perimeter is 12.6 meters. So this is the kind of work I'd hope to see on your test. If you get a wrong answer and you have no work, I can't give you any partial credit. So the more work you show, the better, the kinder I can be. 4 gives me a circle, and it wants me to find both the circumference, which is kind of the perimeter of a circle, and the area. And I looked in my sheet and stole these formulas. For this circle, the number that's given is the diameter. It's the distance all the way across the circle through the center. And I'm going to divide that by 2 to get 6 centimeters for the radius. When I go to do the area, I'm going to use the pi r squared formula. I'm going to leave my answer in terms of pi, and my units are going to be square centimeters. So for my area, I'm going to go pi times 6 squared, and I'll leave the pi and I'll square the 6. That's going to give me 36 pi. And when I write my answer for area, I'm going to write the number 36 pi, and my units are going to be centimeters squared. Circumference is like perimeter, so when I go to write my answer for the circumference, the units are going to be like perimeter. They're not going to have a square. To find the circumference is just 2 pi r, so it's going to be 2 pi times 6. And when you do that multiplication, you just multiply the 2 and the 6. You leave the pi, so the circumference is going to be 12 pi for a number, and then centimeters for the units. When we go to do the shaded area, the first thing I usually do is find the area of the unshaded part. Then I find the area of the big shape, and then I subtract the 2. So first thing I'm going to do to find number 5, which is the shaded area, first I'm going to find the area of the unshaded part. And that unshaded part is that triangle. And that triangle, I'm assuming this 9 centimeters is the base. And I'm also assuming that this 4 centimeters is the height of this triangle. So that this triangle, when I go to find its area, I'm going to use the formula base times height over 2, which is given on this sheet. I just stole it from here, so I didn't have to look back at it. The unshaded area of the triangle is the base of the triangle, which is 9 centimeters, times the height of the triangle, which is 4 centimeters over 2. This comes out to be 18 square centimeters. Next, I'm going to do the area of the, I'll say of the entire figure, which is this big rectangle. That big rectangle has 2 dimensions that I need. It has a width of 4 centimeters and a length of 12 centimeters. So the 2 dimensions I need in the rectangle are the length and the width. I usually make the width the shorter leg and the length the larger. And for the area for the rectangle, I'm going to use 12 times 4 and get 48. Now I subtract the bigger minus the smaller number. When I go to get my answer, the shaded area that I need to compute can be computed by taking the area of the big rectangle minus the area of the unshaded circle. The number is going to be 30, but I need to have units in its area, so it needs to have square units. My answer for 5a, I'm going to write a for area, 30 for the number, and my units are going to be centimeters squared. Same sort of thing for part B. I'm going to find 2 areas. I'm assuming both of these are circles, and I'm leaving my answer in terms of pi. So first I'm going to find the unshaded area. And the unshaded area is this internal circle. So I'm finding the area, yeah, beautiful, of this circle that has a radius of 11. The area of that's going to be pi, has an area, a radius of 10, times 10 squared. The area of the unshaded part is going to be 100 pi. Then I'm going to find the area of the big shape, the big circle here. And this big circle when I go to find its area, it's a little bit tricky because the radius of this is the 10 meters from the little circle plus the 1 meter from this band. Its radius is going to be 11 meters technically. The area of the big shape is going to be pi times 11 squared, and 11 squared is 121 pi. So I've computed two areas. Now I'm going to subtract to get the shaded area. The shaded area is going to be the bigger number, 121 pi, minus the smaller number, 100 pi. And when you subtract, the pi's don't change. I just have to subtract the 121 minus 100. The pi's kind of work like x's in some sense. And 121 minus 100 is 21. The numerical part of my answer to the area for 5b is 21 pi, but I need units. And because the lengths are in meters and its area, I'm going to have meters squared. So my answer to 5b, I'm going to say A for area is 21 pi, and then units are meters squared. Two more shaded areas. I think I got crazy with these. First thing in problem 5c, I'm going to find the area of the unshaded part, which is that rectangle. And that's an easy area. That's just a baby rectangle. I just multiply the length times the width. It's got to be 2 times 7. The unshaded part has an area of 14. And then I'm going to do the area of the big shape. And that looks like a square, but it's yet a rectangle. So then the big area, it's another rectangle. I'm going to multiply the two sides, 10 and 12. And get 120, and then to find the shaded area, I subtract. I take the big area, 120, minus the unshaded area, 14, and I get 106. I could do that on my calculator if I couldn't do it in my head. That's the number for my answer. I'm going to write A for area in my answer. The number's going to be 106 because the units are in meters and its area, my units need to be square meters. Last one of these shaded areas. First, find the unshaded area. My unshaded area is a circle that has a radius of 3. So my unshaded area is going to be A equals pi times 3 squared. That's going to be 9 pi. Then I'm going to do the area of the big shape. That big shape is also a circle, so I'm using the pi r squared formula. In that big shape, the radius is 8. So my area is going to be pi times 8 squared, which is going to be 64 pi. And then what I need to find is the shaded area. And I get that by taking the 64 pi minus the 9 pi. I really just have to do 64 minus 9 because the pi is going to stay. The numerical part of my answer is 55 pi. When I go to write my answer, I need units. And I might say A for area equals 55 pi, and then my units have to be centimeters, but now we're into volumes, which means we have to recognize the names of the shape. This I could look through, so it's some sort of prism. And because the side I can look through is a triangle, it's a triangular prism. So I had to identify the shape because the shape wasn't given to me on the formulas. I found the formula 1/2 base times the height times the length, and now I'm going to use that formula. The base times the height comes from the triangle. So the numbers I'm going to need in the formula, the base is going to be the 8 because it's the base of the triangle. The height is going to be the height of the triangle, which is the 10, and then the third length must be the L. So for my volume, I'm going to go 1/2 times base of 8 times height of 10 times length of 20. I'm just going to do this all in my calculator. I don't care to do it by hand and make a mistake. I'm going to put each of the numbers in a parentheses instead of putting time signs. Doing that on my calculator, 1/2 times 8 times 10 times 20 will give me the right number. So V for volume, 800 is the right number. Centimeters is kind of the right unit, but volume you need cubic units. So my answer to 6A, the volume is going to be 800 cubic centimeters. 6B comes to a point, it makes it a pyramid, and so I couldn't look through it because it comes to a point, it makes it a pyramid, and the base here tells me the kind of pyramid it is, and this is a square pyramid because the base is a square. So I looked at my formula sheet and I hunted down the formula for a square pyramid and wrote it down, and now I have to identify the pieces. The S in the formula comes from the sides of the square, so the S is going to be the 6. And the height comes from the distance from the top of the pyramid to the center of the square. In this case, that's going to be 8. I'm going to go volume equals 1/3, and then times 6 squared, and then times 8. I'll do this on my calculator the best I can again. So 1 divided by 3 in a parentheses for the 1/3, and then parentheses 6 squared, and then parentheses 8. That looks close enough to that I'm going to be happy with the number. Part of my answers, the numerical part is going to be 96. Because it's volume, I need cubic units, and because these are inches, I need cubic inches. So my answer to 6B, the volume is 96 cubic inches. For 6C, I have to do 2 separate volumes. I have to do the roof, which is the harder part of this kind of house. And this roof, I can look through it, so that's a prism, and this base is a triangle, so it's a triangular prism. So let me do the top first, which is marked in pink. I'm going to find its volume. The volume formula for a triangular prism is 1/2 times the base times the height times the length. The triangle part here gives me the base and the height. I'm assuming that this little 4 is the height. So for the triangular prism, the height is 4, and the 8 that's down low from the base, I'm going to bring up here. That's the base of the triangle. So the triangle is a 4x8 triangle, and then this length right here is the off length. That's going to be the L for the triangular prism. So the 3 sides I need in the triangular prism are a base, a height, and a length. The base is going to be 8 centimeters. The height is going to be 4 centimeters, and the length is going to be 5 centimeters. When I multiply those out, I can go 1 divided by 2 times 8 times 4 times 5. I get the volume, the numerical part of the volume is 80. The bottom of this, I'll do in a different color, is just a box, and a box is a rectangular prism. And these are the easiest volumes to do because you just have to multiply the 3 individual lengths. And the 3 individual lengths associated with the box are this 6 centimeters, that 8 centimeters, and that 5 centimeters. Those are the 3 lengths on the box. For a box or a rectangular prism, you just multiply those 3 lengths. It really doesn't matter what you call length and width. I would probably call this the length and this the width, because this is the face that has 2 sides measured. It's a rectangle, and in rectangles I make the shorter side the width, the longer side the length, and then this off side must be the height. Seems an odd way to describe it, but that's probably how I would do it. To find the volume, I'm just going to multiply the 3 sides in any order that I choose to multiply them in. So 6 times 8 times 5, I could do it with or without parentheses. That gives me 240. And then for my answer, I need to add these together, because I'm adding the volume of the bottom to the volume of the top to get the combined volume. And 80 plus 240 is 320. So the numerical part of my answer for 6C is 320. Of course, I need units. I'm going to write V for volume. The numerical part is going to be 320. These are in centimeters, so I need centimeters in my answer. It's volume, so I need centimeters cubed. So many problems. This is a cone. It's not a pyramid because the base is a circle. Cones have circular bases. I stole this formula. I wrote it down here. There's only two parts to measure that I need for my formula. The R comes from the radius of the circle, and the height comes from the top of the cone to the center of the circle. So the H and the R are easy to figure out. And in this problem, it doesn't say round to 2 decimals. It does say leave pi in my answer. If I write my answer with 2 decimals, I'm not going to care. But I probably would prefer a fraction when it doesn't say round to 2 decimals. Let me figure out the decimal part of my answer and then a fraction part. Both of them I'm going to ignore the pi. To get the decimal part, I'm going to do 1/3 times 2 squared times 8. Round to 2 decimals, I'm going to say it's 10.67. If I hit the math button and then enter once and then twice, I get a fraction instead of that decimal. I'd live with either on the test if you get the right units, and the units need to be inches cubed here. So either 10.67 pi inches cubed or 32/3 pi inches cubed, and that pi shouldn't be, there shouldn't be such a gap between the 32/3 and the pi. Is just, it just, for whatever reason, when I was writing, I wrote the pi down early and I didn't really have the room. I don't know, I just messed up. So both of those are correct answers. This is a basketball or soccer ball, which is a sphere. I just snuck out the formula. Volume equals 4/3 pi r cubed. There's no v there in the formula, but it's assumed. So the only number I need is a 4, which is the r. So I'm going to say volume equals 4/3 times pi times 4 cubed. Again, it doesn't say round to 2 decimals. It does say leave pi in your answer. When I go to write my answer, I'm going to have a pi. My units are centimeters because it's volume, it's centimeters cubed. And now I'm going to figure out what 4/3 times 4 cubed is. As a decimal, it's 85.33. I'd completely live with that as an answer. It's not terribly hard to make a fraction answer. I just hit the math button and enter twice. And I'd also accept 256/3. The instructions technically didn't say round to 2 decimals, but I can't ever imagine taking off for you rounding to 2 decimals in our class. So both of those would be acceptable answers. On my answer key, I have the 256/3. One last volume problem. And this problem's tricky because it has a top and a bottom and a middle. The middle is like a Coke can, and a Coke can is a cylinder. So let me do the middle first. For a Coke can, the formula's volume is pi r squared h. The r is going to be this 6 meters, and the height is going to be the 11 meters. So for the volume of the cylinder, it's going to be volume equals pi times 6 squared times 11. I'm going to leave the pi alone, and I'm going to figure out what 6 squared times 11 is. And that's going to give me 396 pi. That's the easy part of this. The other part's not supposed to be so hard. For the other part, you're supposed to imagine the top and the bottom are both half of a soccer ball. And if you put the top and the bottom together and combine them, I can't really draw these so well. These combined make one complete sphere. So combined, if you took the middle out and push the top and the bottom together, you'd get one complete sphere with a radius of 6 meters. So the volume of the top and the bottom combined, I'm going to do one computation of a volume of a whole sphere because these together make a whole sphere. So this part, the volume is going to be 4/3 times pi times 6 cubed. I'm going to leave the pi and figure out what 4/3 times 6 cubed is. That's apparently 288. So the volume of the sphere numerically is 288 pi. I need to add these together. So the combined volume is going to be my answer. It's going to be 288 pi plus 396 pi. My answer is going to have a V for volume, a pi because the pi is going to hang around. The numerical part is whatever 288 plus 396 is. In this case, it's 684. And then I need units. It needs to be cubic units because it's volume, and the lengths are in meters, so it has to be cubic meters. So 684 pi cubic meters, I think, would be perfect for 6F. I don't even have an answer to 6F on my key. Maybe I deleted it and forgot to delete it from the sheet. But there it is anyways, just in case you were looking for it. So for the rest of the problems, it's the dimensional analysis, and I wrote what I needed. So I looked at this sheet, figured out what I needed to convert 15.25 liters to milliliters, and it's simple to do. To convert 15.25 liters to milliliters, I took the metric chart that I had for liters, and I need to come up with an equivalence, and the equivalence is going to be 1 liter equals 1,000 milliliters. And I need to multiply by a fraction. In the numerator, it's the unit I want to end up with, which is milliliters. In the denominator is the unit that I want to get rid of, which is liters. I'm going to put 1,000 next to the milliliters, 1 next to the liter. The liters are going to cancel. The numerical part of my answer I just get by taking 15.25 and multiplying it by 1,000, which is 15,250. And the units are milliliters. My answer to problem 7 is 15,250 milliliters. So 8 was horrible. So I wanted to go from ounces to liters. I'm assuming I'm in fluid ounces. And so I looked through my list of ounces, and I had a relationship between ounces and milliliters and ounces and cups. I didn't think ounces and cups were going to be helpful, so I used the relationship between ounces and milliliters. And what I could start off doing is I could say that 50 ounces can be transformed into milliliters by using this unit, by putting milliliters in the numerator and ounces, or fluid ounces, in the denominator, putting a 30 next to the milliliter and a 1 next to the ounce, or fluid ounces. What that's going to do is it's going to take me out of ounces into milliliters. I want to end up in liters, so I need to multiply by another fraction. And that next fraction is going to have milliliters in the denominator to get rid of the milliliters that I'm temporarily in, and liters in the numerator to get into the liters that I want to get into. And I'm going to use that same relation that 1 liter is 1,000 milliliters. So I'm going to put a 1 next to the liter and 1,000 next to the milliliter, and this is going to take me to my answer if I do the work right. I'm going to go 50 times 30 and then divide it by 1,000. So 50 times 30 divided by 1,000. The numerical part I get is 1.5. The units are liters. So my answer to number 8 should be 1.5 liters. And I can just write it right there and be done. For number 9, I needed to convert from miles to kilometers, and that's an easy one because I have the unit that 1 mile is 1.6 kilometers, so I'm going to use that. And then I'm going to multiply. I'm going to start off with my 22 miles. I always multiply by at least one fraction. The numerator has the units I want to wind up with. I want to wind up with kilometers, so I have kilometers in the numerator. The denominator has the unit I want to get rid of. I want to get rid of miles. The 1.6 goes next to the kilometers, 1 next to the miles. My miles cancel, and I multiply the numbers because the 1.6 is in the numerator. So I just go 22 times 1.6. I get 35.2 for the number, and my units are kilometers, so the answer to number 9 is 35.2 kilometers. When I went to do number 10, I started with kilograms. I want it to go to ounces. So I went into my weights and I looked for kilograms, and I saw 1 pound is 0.45 kilograms. I said, well, that's a good place to be, but that's not enough. So the first thing I decided I was going to do, I was going to use that. I was going to take my 18 kilograms and I'm going to multiply it by the only weight that has kilograms, and I'm going to put kilograms in the denominator and pounds in the numerator. I'm going to put a 0.45 or a 0.45 next to the kilograms, a 1 next to the pounds, and what that's going to do is it's going to cancel out the kilograms and put me into pounds. Unfortunately, I need to get to ounces, and I looked here, I said, oh, I can get from pounds to ounces by using 1 pound is 16 ounces, and that's the next unit I decided to use. I'm going to use this unit properly. I want to get rid of the pounds, and I want to end up with the ounces, so I put pounds what I want to get rid of in the denominator, ounces that I want to wind up with in the numerator. I'm going to put a 1 next to the pound, a 16 next to the ounces, and now the pounds are going to cancel. I have the unit left that I want. I multiply numbers in the numerator, divide numbers in the denominator. I do the divide last. So here I'm going to go 18 times 16. I don't worry about the ones. Divide it by 0.45. That's going to give me the number part, which is 640. And the unit that didn't cancel is my ounces. So the answer here is going to be 640 ounces. When I go to do number 11, I'm converting from yards to meters. This is length, and the beautiful thing, there is this wonderful relationship between yards and meters. I found the unit that relates yards and meters, so I'm going to use that 1 yard is 9 meters. For this problem, I'm starting off with 20 yards. I multiply by a fraction. I want to get rid of yards, so the yards go in the denominator. I want to end up with meters, so the meters go in the numerator. 1 goes next to the yard. 0.9 goes next to the meter. My yards are going to cancel. I multiply the number because the 0.9 is in the numerator. I just do 20 times 0.9. The numerical part of my answer is 18, and the unit part of my answer is meters. Is all converting within the metric system. I'm converting from meters to kilometers, so I need to create a unit out of this table. I'm going to use the fact that 1 meter equals 0.001 kilometers to do my change. So I'm going to start off with 5,234 meters, and I'm going to multiply by a fraction. It's going to have meters in the denominator because I'm trying to get rid of the meters. I'll put the 1 next to the meter. It's going to have kilometers in the numerator because I'm trying to end up with kilometers. And I'm going to put the 0.001 next to the kilometers. I'm going to cancel the meters. I'm going to multiply these numbers. And I get 5.234 for the numerical part of my answer. No need to round that to 2 decimals. You can if you want, but it just came out and it's not so hard to write. The instructions didn't ask me to round, so I just kept all those decimals. So my answer for 12 is going to be 5.234 kilometers. For 13, I have a pool that I'm assuming this pool is a rectangular prism. And in part A, I'm asked to find the volume of that pool. To find a volume of a pool or a rectangular prism, you multiply the 3 numbers, the length, the width, and the height, and in any order. So I'm going to multiply the 15, the 13, and the 4, get a number, then I'll attach my units. It's volume, so I get cubic units. The numerical part for problem A, the number is 780, and my units are going to be cubic feet. So the answer to part A, the volume of this pool in cubic feet, is 780 cubic feet. For part B, how many gallons can it hold? And when we did the gallons computation, we had this 7.48 gallons as 1 cubic feet. That's the relationship I'm going to use to do the conversion. So I'm going to take the 780 cubic feet that I have. I want to change to gallons. I want to get rid of cubic feet, so the fraction I have is going to have cubic feet in the denominator. I want to end up in gallons, so the gallons is going to go in the numerator. 7.48 is going to go next to the gallons, and 1's going to go next to the cubic feet. I'm going to cancel the cubic feet, and I'm just going to multiply the 780 times the 7.48 to get the number part of my answer, which is 5,834.4, and then the units that are left are gallons. So the answer to part B, how many gallons does this pool hold, 5,834.4 would be perfect. Last thing, I kind of don't remember doing something like this in the homework, but I'll do it here. So how many gallons of propane will it take to fill an empty 4 kiloliter storage tank? And there must be a relationship here. There's a relationship, but unfortunately, I'm starting with 4 kiloliters, and I need to convert it to gallons. So this problem is asking me to change 4 kiloliters to gallons. And when I look through my gallons, there's a gallon related to liters, but not a gallon related to kiloliters. So the first thing I'm going to need to do is I'm going to change from kiloliters to liters using this chart, and then liters to gallons, because the only relationship I saw between gallons in the metric system is this. So this is a two-step process. The first thing I want to do is get out of the 4 kiloliter tank into liters. And what am I going to use? I'm going to put liters in the numerator, kiloliters in the denominator. I'm going to put a 1 next to the liter and a 0.001 next to the kiloliter. That'll get me out of kiloliters into liters. Ultimately, I want to go into gallons, so I need to get out of liters. I get out of liters by putting liters in the denominator. I get into gallons by putting gallons in the numerator. Now I'm going to use that 1 gallon is 3.8 liters. The liters are going to cancel, so I'm going to be left with gallons. I'm going to have to divide both of these numbers. So on my calculator, I'm going to go 4 divided by 0.001 divided by 3.8. That's going to give me the number part, and finally round to 2 decimals. I'm going to round this to 1052.63, and my units are going to be gallons. I guess I could write the whole word gallons out, or you can do some sort of abbreviation that feels like gallons to you. So I moved kind of fast with the idea you weren't watching every problem on this. So if you've perfected every problem on this practice test, then you're ready for the test in terms of the first part of Chapter 2, and then we just have the next part to deal with here in a week.